Hey everybody, this is video number 3 for the 3.3 notes. So we're going to finish it off here. So we got the back page of the notes, and it says if a billiard ball is dropped from a height of 100 feet, its height s at time t is given by the position function s of t equals negative 16 t squared plus 100, where s is measured in feet and t is measured in seconds. Find the average velocity over each of the following intervals. So what you want to remember here is average velocity is slope. So basically, we're trying to find the slope of this function. So we're going to do s. Let me pick a different pen. Sorry about that. We're going to pick s of 2 minus s of 1 over 2 minus 1. That's our y2 minus y1. Now, for something like this, especially because we're going to have to do multiple values, we're going to use the graphing calculator. So if you take out your Inspire, the first thing we're going to do when we want to calculate a function at multiple points is we're going to store that function in our calculator. So we're going to go ahead and go s parentheses t, close the parentheses. Now to store a function, you're going to hit Control and then this button here. So you should have this colon equal sign. At that point, we should be able to type in the function negative 16 times t squared plus 100. After we're done entering it, we're going to hit enter. Now it should say done. Once it does that, now if I want to find or calculate the value of this function at any given time, such as 2 and 1, I can go s parentheses 2, enter, and get an answer. S parentheses 1, enter, and get my answer. So it becomes much faster to come up with those. So if we go back to the notes, we're going to have 36 minus 84 in the numerator. So we're going to have 36 minus 84, and then 2 minus 1 is 1. If we simplify that down, we get negative 48. And then we want to make sure we come up with units. So the height is in feet, time is in seconds, I believe. Yes, time is measured in seconds. So this is going to be negative 48 feet per second. And that would be the average velocity of the billiard ball on the time interval from 1 to 2. The only difference for the other problems is we're going to do the same thing over different intervals. So if the interval is 1 to 1.5, we have s of 1.5 minus s of 1 over 1.5 minus 1. I'm going to go back to the calculator to get at least the s of 1.5 value because we already know the s of 1 value. So on the calculator, we can simply, because we stored the function, s parentheses 1.5, close the parentheses, enter, and we get 64. So if we go back to our problem, we're going to have 64 minus 84 over, now this time 1.5 minus 1 is going to be 0.5. So if we simplify that, we've got negative 20 divided by 1/2, which is negative 40 feet per second. So that's the average velocity there. And then if I want to do it the same thing over the interval from 0.9 to 1.1, which gets closer and closer to time t equals 1, we're going to have s of 1.1 minus s of 0.9 over 1.1 minus 0.9. So again, go back to our calculator. All we have to do is s parentheses 1.1, hit enter. That gives us 80.64. We need s of 0.9 as well. Nope, it's not 0.09, 0.9. And that's 87.04. So if we go back, we're going to end up with 80.64 minus 87.04 over 0.2. And I'm going to go ahead and use the calculator for this. So we're going to have 80.64 minus 87.04. And then we're going to divide that. Whoops, I did not do that right. Hang on. Okay, 80.64 minus 87.04. And then we're going to divide that by 0.2, and we get a value of negative 32. So in that case, we're going to get negative 32 feet per second. And those are all average velocities of that billiard ball over given intervals. All right. Now, there's some questions below. One says, how could we estimate the velocity at t equals 1? Okay. So one point to estimate the velocity is to do what we just did. Find the slope of the secant line over given intervals. Now, the smaller that interval is, the closer that estimate should be to the actual value of 1. So you can kind of pay attention up here. You know, we went from 1 to 2, we went from 1 to 1.5, and we went from 0.9 to 1.1. C would probably give, well, C would definitely give us the best estimate because we're taking points on either side of 1 closest to 1. All right. But basically what we can do to estimate slope is use the slope of the secant line. Using values close to 1. Now we don't want to use 1 typically, we want to be on either side of 1. Now, if we wanted to find the instantaneous velocity at t equals 1, then we would want to use the derivative. So instantaneous velocity is the same thing as the derivative. Okay, so what we would want to do is we would want to find s prime of 1. Okay, that's the derivative. Derivative of s at t equals 1. And that would give us the instantaneous velocity at t equals 1. Okay. Now here it says, at what time does the instantaneous velocity equal 0? Well, we basically want to know, when does s prime of t equal 0? Because the instantaneous velocity is the derivative. So we want to know, when does the derivative equal 0? So from the function above, all right, we have s of t, which is negative 16t squared plus 100. If we take the derivative and find s prime of t, we can apply the power rule. So we're going to multiply by 2, we get negative 32t, reduced by 1, so 2 becomes 1, and then the derivative of the constant 100 is 0. So our derivative is negative 32t. We want to know when that equals 0. So we're going to replace s prime of t with negative 32t equals 0, and then we solve. So if we divide both sides by 32, t would equal 0 seconds. So in this case, the instantaneous velocity is going to equal 0 at time t equals 0. All right. Our next question says, what are the units for instantaneous velocity? So the instantaneous velocity is going to be the change in height over the change in time. Okay? So if we look at this function, change in height over change in time, that's going to give us units of feet, because height is measured in feet, over seconds, because time is measured in seconds. So feet per second. Change in height over change in time. All right, the next question says, on the interval 1 to 2, at what time does the instantaneous velocity have the greatest magnitude? All right, so now the instantaneous velocity, we're going to find that by taking the derivative. So s prime of 1, and we're going to find s prime of 2. And we can do that fairly easily right now because we know that s prime of t is negative 32. So this will be negative 32 times 1. This will be negative 32 times 2. So we get negative 32 feet per second. Here we get negative 64 feet per second. Now, negative 32 is a bigger number than negative 64. But when we refer to the magnitude, we don't care about the sign. All right? So magnitude is which is the larger value. In this case, 64 is larger than 32. So there's the greatest magnitude happens at t equals 2. All right. The last thing that we're going to talk about, and we will definitely explore this more later on, but what is the relationship between velocity and speed? All right. Velocity and speed have this relationship. Speed is going to equal the absolute value of velocity. Okay. Because when you're talking about velocity, the sign is typically going to tell us the direction that it's moving. Is it moving right? Is it moving left? With speed, we don't care about direction. Okay? So it's always going to be the absolute value of velocity. All right, guys, that is the end of video number 3 for 3.3. Hope you found it useful, and I will see you later.